Hi everyone. Scatter plots are highly effective, but you have to understand that there is no universally optimal type of data visualization. Instead, the visual representation that you use has to be adapted basis the specifics of the dataset and the type of question that you're trying to solve. Now, with some datasets, you might want to understand changes in one variable as a function of time. So this is where we look at continuity with line plots. Now in Seaborn, there are different functions available. So we have, of course, our line plot, but there is another option. We can use the rel plot, something that we did earlier, but we will use our rel plot and change the setting, which is the kind, to a line. So both of these work perfectly. You can either use the line plot directly, or you can use rel plot and change the kind to a line. Let us take a simple example. So we will define a data frame. So we have a pandas data frame here, and let us create time is equal to numpy dot a range, and we will choose 500. Then the value, we can choose a random set of values. So we choose random numbers, and then comes sum. Don't worry if you don't understand each part in this. When you study pandas and numpy, this will be clearer. In any case, this is just an example to show you how a line plot would look. As I mentioned earlier, we will keep x as our time, but you notice we are still using our rel plot. Y will be the value, and then in the kind, we will select the line. And of course, the data would be equal to the data frame that we have created. Now let's plot the visualization. So auto fmt x date. Again, you can Google it to see what it actually does. But for now, we are just concerned with this. Let me quickly check if there's a small mistake somewhere. Okay, I will also have to import my relevant libraries. So we'll simply say import pandas as PD, import numpy as np, and import seaborn as sns, and we will also import matplotlib.pyplot as plt. Okay, so we run it, and as you can see, we have created these different values, and obviously these are random. So if you rerun this every time, you notice that the visualization changes. But this is how a line plot would be presented. And the reason you don't want to use a scatter plot here is because you're presenting a value over a period of time, which is on the x-axis. Now, because line plot assumes that you're most often trying to draw y as a function of x, the default behavior is to sort the data by the x values before plotting, right? So the default behavior is to sort the data by the x values before plotting, but you can disable it if you want to. So let's again define a data frame. So we have pandas dot data frame np dot random dot random number 500 2, and then we will have CumSum. We will keep the axis as 0, and we will also keep our columns equal to x and y. Then we have our rel plot, where we say that x is equal to x, then y is equal to y. Our sorting is false, so this is what we are changing compared to the previous example, and the rest is the same. So we have a kind which is equal to line, and then we have the data which is equal to the data frame that we created. So when we run this, let's quickly see, one moment. Okay, so when we run this, you notice we get a data set like this, we get a graph like this. Now don't worry about how it looks. This was just to show you that in case you want to disable the default behavior of the sorting, you can do that. Now let's look at aggregation and how we can represent uncertainty. Now when you have a more complex data set, it will have multiple measurements for the same value of the x variable. Now the default behavior in Seaborn is to aggregate the multiple measurements. So the default is to aggregate multiple measurements. Now this means that at each x value, so we are aggregating at each x value by plotting the mean and the confidence interval. Now the confidence interval by default will be 95%, which is around the mean. If you're not comfortable with terminologies like confidence interval, I would suggest you quickly Google it and just get comfortable with what a mean is and what a confidence interval is. Let's take an example. So we will take the fMRI dataset. This again is a inbuilt dataset available inside Seaborn. So if you Google it, you can even download it. But for now, we are just concerned with creating a rel plot. And here we will say that x is my time point and y is the signal, the kind is line, and the data is the fMRI dataset. And it doesn't work. Let me just quickly check this. So we have, okay, I misspelled this. So this should be signal. Excellent. So as you can see, we get the data set here. Now the confidence intervals that you see here are computed using bootstrapping. So I just mentioned that. Computed using bootstrapping. Again, you can Google it to see what the term stands for. Now, the problem is that this can be very time intensive for larger data sets. So there might be a need for you to learn how to disable the bootstrapping. So it's very simple. You can simply copy this line. And the difference is that after choosing the signal, we will also say that Ci is equal to none, which basically means that we are changing the confidence interval disabled. And now when you notice, we will only get our line, we will not get the error margins. Now, another good option, especially when you're working with a larger data set, is to represent the spread of the distribution at each time point by plotting the standard deviation instead of a confidence interval. So the difference here is we want to look at plotting the standard deviation. How do we do this? We can copy the line and simply replace where we have written the Ci as none, we will put SD for standard deviation. When you run this, we get a result like this. All right. Now let's also look at semantic mappings. So similar to the scatter plot, we can show up to 3 additional variables by modifying the hue, the size, and the style. Now we use the same APIs that are available in scatterplot, which means that it's not really going to be very difficult. Let's take an example. So we'll copy the same data set, but this time we also want to keep a hue, and the hue is the event. Let's remove the standard deviation for now, and you notice that we get a result like this. So we have two different lines that we can see. Now you can also add a style semantic to a line. So this time we want to write Y is signal, hue is region, and hue is our region. And we will also keep our style as our event. So this time you notice that we get a dashed line as well. So we get two regions and two events. You can you can identify subsets by the markers used at each observation, either together with the dashes or instead of them. For example, let me just copy the same thing. So we have to add two elements here. One is dashes has to be false, and the other is the markers has to be true. Right? And the result changes like this. Now do remember, just like scatter plots, you have to be very cautious when you're making a plot using multiple semantics. The reason is that even though they are very informative, it is also very difficult to parse and interpret it. So please make sure that when you're using it with a lot of caution, especially when you have both the color and the styles. It can be a little overwhelming. Why do we use it then? We use it typically when we want to create some accessibility. For example, we want to print it in a black and white format, or we want to send it to somebody with a color blindness accessibility. Okay, so let's see what else we can do. Let's take one more example. Now remember the default color map depends on the hue semantic, whether it is categorical or numeric. So we will take a different dataset now called the dots dataset. Like earlier, this is also an inbuilt dataset available in Cbol. And we will say dots. Then we have to query. And because we only want to take one value, so from align, we will take the dots value. Then we will plot. So we have a rel plot where x is equal to the time. We have y is equal to the firing rate. The hue is the coherence, and the style is equal to the choice. The kind is line and data is dots. Let's quickly check this. So as you can see, we get the coherence on a numerical scale, and we have the choice on a categorical scale, T1 and T2. Now it may happen that even though the hue variable is numeric, it is poorly represented by a linear color scale. And if that is the case, where the hue variable is logarithmically scaled, you can provide specific color values for each line by passing a list or a dictionary. It will make more sense when we do the example. So this time I want to first create a palette, which will be my cube helix palette. So you can just Google this, the cube helix palette, and we will keep the light as 0.8 and we will keep the number of colors as, let's say, 6. Once we have done this, the rest can simply be copied. So we have our time, firing rate, coherence, choice. Then we also want to put our palette here. And when we run this time you notice that earlier the coherence was 0, 20, 40, and 60, but this time we are able to use the coherence on a numerical scale as per what we decided, right? And you will notice that it looks a little better. These numbers, of course, can be customized as per your need. You can alter how the color map is normalized as well. So if you want to normalize it from matplotlib dot colors, we first want to import log norm, and then we will copy everything here. And let me see if I want to change something. So let's just make this 0.7 for now. And instead of the palette, this time we will say that the hue norm is equal to the log norm, right? And I get a logarithmic scale right now. The third semantic that we have is the size, which allows you to change the width of the lines. To do this, we will simply put the time, the firing rate, the size is coherence, the style is choice, kind is line, and data is dots. So you notice this time the width of the lines is also changed. Now, while the size variable will typically be numeric, it is also possible for you to map a categorical variable with the width of the line. But be careful about this because the difference between thick and thin might not be very apparent to a user. But let's take an example. So this time we will keep the hue as the coherence. I will keep the size as my choice, and we will also keep the palette as palette, like this. My personal suggestion is use it, but with caution, right? There are advantages of having a thin and a thick line, but be very careful when you're working with this. Let us now look at how we can show multiple relationships with facets. Now we have seen in the examples that functions can show several semantic variables at once, but despite that, it is not always effective to do so. But then what do we do when we want to understand how a relationship between two variables depends on more than one other variable? Now the best approach may be to make more than one plot, because rel plot is based on the facet grid. This is very easy to do. So to show the influence of an additional variable, instead of assigning it to one of the semantic rows in the plot, we will use the facet grid for the visualization. To make it simple, what does it mean? It means that we can have multiple axes and plots. So we can have multiple axes and plots on the subset of the data. Let's take an example. SNS.rel plot. X is total bill. The Y is equal to the tip, and the hue is equal to the smoker. So we're using the tipping data set here, right? So the data set is tips. The column is equal to time and the data is equal to the tips data. And it says it's not there. Hold on. Have I not loaded it? One moment. Okay, I think we did not load the data set. Never mind, I'll do it once again. So we will load our tips data set. This time, as you can see, we are getting two different facets inside. Now we can also show the influence of two variables this way, one by faceting it on the column and one by faceting it on the rows. So as in how you start to add more variables to the grid, you may want to decrease the figure size. Now remember, the size facet grid is parameterized by the height and the aspect ratio. Let's take an example. So sns.relplot, our x is the time point, y is the signal, and the hue is the subject. We'll keep the column as the region. We will keep the row as our event, the height as 3, the kind as a line, and the estimator would be none, and the data would be fMRI. Okay, so this time you notice we get 4 different blocks here. So we have the signal and the time point on the y and the x axis, and there are different subjects that are represented.